so you don't have to rewrite code.
All right, just to recap, the classes, the declaration, and Java docs, how to write a Java docs. Then we just covered inheritance. You said, repeat what you said for me, please.
Pretty much, it's where you can write a method that extends another method, so you don't have to reuse the code. You don't have to rewrite code since you already wrote it earlier.
Good. In terms of, yeah, okay, I was thinking. So then that's for classes, and then the method overriding. There's two on. There's method overloading and method overriding. What is method overriding? Back to what you said about code reusability. It's used with an inheritance. So like, for example, you have a generic shape class and then you have a circle, right?
Yeah.
You have different ways of calculating area, for example. So for a shape doesn't provide a way to calculate area. So then you would, in the circle class, you would define a way to calculate that area. That is an example of method what? Right. So say what is it? What is the rule? All squares can be rectangles, rectangles can't be squares. So say you have a rectangle class, and then you have a square class that inherits rectangle, and then the square would then override the calculate area, because with a rectangle, it's length times width, right? Mm-hmm. But with a square, it's just, what is it? Length squared, right? So for an example of overriding in this case would be rectangle may be length times width when it calculates area, but in the square class, when it overrides, it would just be length squared. That'd be one example of overriding. When I pull up the projector, I'll give a more concrete example.
You said the square class would be inheriting the rectangle class.
Right.
So would you have to, on the squares, on the square class, would you have to put the override at override? Would you have to put
the annotation?
Yeah.
I think if you don't put it, I think the compiler is intelligent enough to realize, hey, you've got two symbols with the same name. It can intelligently say, hey, you're overriding this method, but it's always better to explicitly write that the override annotation, because explicit is always better than implicit. But I think if you were to omit it, Java would allow you to. It would just, it would see that you're doing it. We can test it when I go to write it or write a concrete example. So that's overriding. We got polymorphism. So it's polymorphism.
At the beginning, and everything that's in the template works.
But if you leave it
it doesn't load anything.
Hey guys,
so
Taylor.
your pages.
I'm recording. If you could not, okay, sorry.
Yeah,
So polymorphism. Something changes. So an example of inheritance. So polymorphism. So say you have a container that is back to the square rectangle example. Say you have container. Say you have an array of rectangles. Could you put a square into it?
Yes.
And that is an example of polymorphism, because you're treating the square is a specialized case, right? But we're treating it like the generic rectangle. So we can have a collection of both rectangles and squares, right? So that's polymorphism. Well, you can do a concrete example of that once we check everything off the list. So I kind of talked about it with the shape class, but so abstract classes. That's the most generic you can get. What is an example of a abstract class? Can you instantiate abstract classes?
No.
No, you cannot. So can you think of an example of an abstract class?
No.
So think of the square rectangle thing. What would be a generalization of these two objects? Shape, right? So you could do declare an abstract class called shape, which would then provide, I won't say templates. It would provide what are they called? I can't think of a word. It would provide the abstract methods, right? So it would be a method without a body. You would provide all the things that you want to define in an actual concrete class. For example, that calculate area. So shape would have a declaration for calculate area, which does not have a body because we don't know what shape we're talking about when we're generalizing that much. So we would just say, I have a method called calculate area. However, you don't define it. But then when you inherit or when you extend it or implement it, that's when you then define like actually how to calculate an area of a shape. So that's abstract classes. Kind of talked about it when I was talking about polymorphism, but let's move on to arrays. Are we all comfortable with how to declare an array?
Sort of.
So these would be, there's two, the two different ones, the built-in Java arrays that you can do without importing array list, and then array list, which you have to import, and one's an object and one isn't. So let's look at an example on how to declare the built-in array.
Wouldn't that just be like int?
So we want an integer array.
Yes,
So
int bracket.
now, do the brackets come before or after the identifier?
Either one.
It doesn't matter? Okay, so we do brackets that say that it's not just a singular int, it's multiple int array, right? And then we could just say my ints or whatever. So there's two different types of arrays that we've covered. We covered the absolute ones, and then I can't remember the name. We called them, what were the two different ones? Do you guys remember?
Two-dimensional arrays.
Not quite. So there's the arrays that you declare with all of the elements it's going to have. I think those are absolute arrays, right?
Yeah.
And then you can define an arrays that just have a number of elements that they store without defining what goes into it. There's two different names for them. Let me see if I can find that real quick, because that might be an exam question, right? Absolute arrays versus different Can't find the specific names we use, but you know that. Are you familiar with what I'm talking about? Like, for example, I can say 1, 2, 3, right? And that's an absolute array because I'm up front saying these are all the elements that are stored into it, and these will always be the elements that are stored into it, unless you change. Like, for example, you could change this to 0, change this position, array index position to whatever number you want. Where do you start indexing? What is this position?
0.
Good. The other way we do it, and the I guess not the more powerful, I'm gonna say uncertain. How do I define that array has a specific number of elements?
Go to after the equals sign, put another brace or put another bracket, put
Okay, that's one part of it, and then
3,
3, right?
and then put another bracket that has 3 spaces allocated in that array.
Right. You said more than this?
No, I meant like that's gonna have space for 1, 2, and 3 in
Yes,
the
yes.
same array.
Okay. That's close. There's a little bit more to this. There's two more things we need.
Like new, int.
Yep. Backwards. Okay, yeah, and that's it. So here we have the absolute array, I forgot the semicolon, and then we have an array with 3 elements that are undefined. Those are the two popular, or I think it's the only 2 ways to define built-in arrays, right? These are the important. Remember this. You're probably going to see an exam question that dedicated to this. So, absolute. Don't know what this is called. I'm gonna be honest. Just know that this is how you define an array with this many undefined elements. Are we comfortable with that? Any other questions before I move on? Cool. All right. What else we got? Array list. Okay, so here we have arrays. Let me not use that symbol. Let me not trip over and die. Okay, and then we'll have what is the major difference between array lists and arrays?
You have to import an array list.
Okay, I'm going to assume that I've already done that, so I don't have to write that out. Okay, so I'm going to assume there is an import. What else? What is another major difference between array lists and arrays?
You can just add to an array list, like with the maze solver that we had to do. You could just put like, it was one of the projects we had to do, but you would put like just import an array list and then put add blah 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 blah.
Right. So it you're able to expand it and reduce it without explicitly dealing with the internal arrays. Yeah, that's a good one. More generally, what is a big difference? Does do you have to instantiate arrays? Oh yes, you do, but I guess one's an object and one's built in. Yeah, I think you pretty much covered everything. So when instantiating an array list, how would you declare and then initialize an array list? Yeah, that's the question.
You still want to do it, let's say int. You still want to say int.
Right.
Still the braces.
Right. So yeah, we would use int if we want an integer array. But since it's an object, we have to say that it is of type.
So like public.
Oh well, yeah. Let me give you a name. Public void or public static. So say we have a public static main, etc. Right? How did we declare? I said declare array list. So what would be the object's type, or what is the name of the object that we're declaring?
Array list.
Array list, right? So we start by saying array list, and then what notation or what symbol do we use to say that it's storing integers? I call them diamond notation. But Kara called them something else.
Two greater than and two less than signs on either side.
Right.
Would that be backwards? Because I thought it was what.
Yeah, as long as you have one that opens, right? So you have the, like you said, the less than, and then you would say we would want integer, right?
So the name of the object goes in front of the.
Right. So this goes in front, and then. So yeah, generics is what we call them, right? So we have the array list. That's how you start it off, or list, because list is the interface. Yeah, the list is the interface. So you could also say list here, and you could put an array list in here, but explicitly we want an array list, right? And I'll say, and then how do I instantiate it now? So here we have the declaration with object, generic, identifier. What comes here?
New list.
Right. New array list, right?
Wouldn't you need the actual brackets now?
Brackets are required here. You can put them here, but if you have it here, you don't need it
I
here.
didn't mean the diamond notation. I meant like the actual brackets for the array.
No, brackets are only required with built-in arrays. With an array list, that you treat them like an object. You do need parentheses, however, because a constructor is a method, right? So that's it, right? Can you see this? Cool. I think that about covers array lists. Is there any other questions that you have specifically on array lists?
So the variable type is it's mandatory on the left side, but it's optional on the right side.
Right. Explicitly, it's always good. Like I said, it's always good to be explicit. So it's not wrong to put it here.
Okay.
And in fact, I would suggest that you put it there. But if you don't put it there, it'll still compile.
Okay.
like you said, it's required on my left, your left, yeah. Okay. Everyone's favorite topic, file I/O. Right? So, is there any, like, before I guess get into it, is there any questions about file I/O? Everything about file I/O? That's probably best done with a concrete example, so I'll do a quick concrete example of inheritance, method overriding polymorphism, and then file I/O. So file I/O always starts if you're reading in, the file has to exist. You have to know the path to it, whether it be relative or absolute. You guys know the difference between absolute and relative paths? Sort of. So absolute path is the direct path to it, starting with if you're on Windows, drive letter to a computer. I see why Carol uses caffeine. My computer went to sleep. Yeah, so if you're on Windows, you know the drive letter starting with your users, documents, whatever name of the file, etc. So you have to put in every single folder to that, or every single directory to that path, file name, right? If you're on Linux or Unix, it's whatever your starting path is, and then every directory to it. Relative is wherever your Java file lives, right? So for example, if you try to open as just a file name, it'll always start with the Java or class file lives. For example, if you have if you're working on a project and you have like a my project 2 folder directory, right? And you say I want to open input.txt, right? It'll look where that Java file is stored. So when you go to open it, and of course you've got the plethora of ways to even read those files to begin with. The biggest difference we saw was scanner versus I guess file reader, right? Right, and the biggest difference was when you are reading the next line, scanner does what and file reader does what.
Scanner has next.
Right, and that's required, or else what will happen?
Or you're not going to read it.
Yeah, especially if there's no next line, right? What happens?
Or doesn't it return something like null or something like that?
I think file reader returns null. Scanner does the exception, right? Or do I have that backwards? Let's look it up. That's good old friend Oracle API, right? Okay, so I'm looking for read line, right? So yeah, it has next and has next line, right?
I think so.
Next line. Advances the scanner. It'll throw no such element exception if no line was found, right? So scanner is the one that throws the exception, meaning that while you're looping through the file, be sure you're checking that it has a next line such that it doesn't throw an exception, because that crashes your program, right? Is any of your questions on that?
Doesn't the file and the program have to be in the same folder?
If you're using relative path, right? It does. So like, for example, your text file needs to be in the same place, your Java file needs to be. You could put it in different folders, assuming that you have, the relative path to it. For example, if you say this directory, maybe your, your elements folder. So you have an elements directory, and then in that elements directory, you have a ton of different text files, right? So, and then in your Java program, you say new file, and the path to it is /elements/input.txt. That would work too. It doesn't, as long as, say you have a project hierarchy and you have a file stored within that is right next to your Java files. If you use that relative path to it, you can do it. The reason you'd want to use relative path over absolute is for portability. Not all machines have the same, are going to have the same absolute path, right? So that would be the biggest reason to learn and use relative paths. But for the sake of, like, if you're only using the file name to open and read from that file, then yes, it has to be in the same. It has to be in the same place as your Java files. outputting to a file. Does the file have to exist if you're trying to write to a file?
Yes.
Not always. So if you create a new file and that file does not exist, Java will create the file. Otherwise, yes, it's required that.
Writing to a file?
Mm-hmm. When you're writing to a file, it does not have to exist in all cases. So, and we'll also do a concrete example of that real quick when we check everything else off. And then of course loops are your best friend when writing multiple things or reading multiple things. So be sure while loops, because you never know how long a file is. I think with Scanner you can get a line count. I'm not sure. I would just use a while loop when you're reading or writing to files with data, right? For example, if you have an array list and you're writing to a file, you want to loop through it. If you're reading from a file and you don't know how many lines are in there, you'll read until there is no next line. With a file reader, that's the one that returns null if there is no next line. So you could, while line is not equal to null, you would just keep reading it.
I think Scanner has a thing you can do while scanner has next line.
Right. And yeah, it's either that or exception. So
Yeah, try catch would work.
that too. I think, is try catch on here? Oh, that's the next thing actually. Perfect segue into exception handling. Are you guys comfortable with that? I know we had a ton of exercises involving try catch.
Did you give them a concrete example of the file IO, like an example or anything?
I will. I just want to cover everything and then I'll go into. So I don't have to keep the projector on the whole time.
You know how when you're importing, you can put like import job.util.star and it import the entire
Right.
whatever. Is there any way that you can make an exception catcher that would catch
Everything.
everything?
So inheritance tells us that everything inherits from an object class, right? There is an generalized exception, right? So if you just try and catch exception, yeah, that's pretty much a catch-all. The issue with that is you don't get very much like detail. So it'll always go in. So if you do a catch exception, well, no matter what happened, it'll go there, right? So how are you going to give a detailed report of how your program failed, right? So yes, you can do that. And if it's a very small like lines of codes, like for example, you're only doing file IO and you catch exception, that it was a file IO instruction that caused it, right? But if you're doing a bigger program and you catch only, if you encase your entire program in a catch exception, then you have no idea what went wrong. So while you can do it, I don't suggest it. Is that?
I was
Okay.
mainly asking for the test because, like when we would do the assignments online or whatever, you can like look up what the exceptions are
Right.
that you can actually like try to catch and figure out which one would work for your program. But we're not going to be able to do that on the final.
Oh, so you basically got to remember off the top of your head what the
Yeah.
exceptions are called. All exceptions inherit from the exception class. So I imagine he'd probably want the full name, like you said. It would compile if you did exception, I'm pretty sure. We can do a concrete example of that as well. But yeah, just try to have a collection of what they're called beforehand. I would study that. Everyone's favorite topic, recursion. I'm gonna breeze through this and then I'll do a concrete example of that and I'll give you guys some exercises you can practice. So basically recursion, recursive call base case. Carol had the four, I think was it 4 or 5 tips for, and basically tips and tricks for.
Questions.
What do you want to ask yourself when writing a recursive solution?
Something like that, yeah.
I think the most important one is, can you express the problem in terms of smaller problems? That's the biggest one, right? When it comes to recursion. We can look into, he has them on, do you have the access to the class notes? I think it's, he has all 4 of them listed there. That's what I would review. And then we'll do a concrete example. Generic and interfaces. So generics we covered a little bit with, this is a generic. You can define classes that also have generics. In your class declaration after the class name, you would just say the diamond notation, and then inside of it, give it a name. And that's how you would do generics. We'll do a concrete example of that. And then an interface. Interfaces are a special type of abstract class. They can't. So, like for example, abstract classes can have declarations or definitions. Interfaces cannot. So, like if we say we want an interface shape, you can put method names in there, but you can't define them. With an abstract class, you can. We'll see an example of that. All right, before I move this down and start coding, are there any questions that I glossed over? We good? Yeah? Cheesing?
I had a question about, what was it at?
Interface.
Interfaces?
Yes. That was the last.
Those are probably best seen
Okay.
concrete, but do you have a specific question about interfaces, or do you just wanted me to cover them?
Go over it.
Just go over it?
Yeah.
Interfaces are non-concrete, you can't instantiate them. That's about it. I mean, other than that, that's where all your declarations live. For example, like all of your method names and what they return would go there. You can't, it's a method without a body in interfaces. That make sense? Does not make sense? Need some sleep?
No, I mean, you lost me.
So interfaces are all the methods you said without a body, so.
Like they're just their names, right?
Okay, and they'll be called on by another class that, like extends from this interface.
Right.
And then they'll be defined in that class.
Sorry, say that again.
So the interface just has all these empty methods.
Yeah.
That will be later defined by another class that extends from that interface.
Yeah, typically you want your interface to be higher in the generalization tree, right? So like for example, you wouldn't want to instantiate a generic shape, right? So you would have that as your interface. In fact, that's where I'll start, because if I do a public path shape, that would allow the developer to then instantiate a bunch of shapes. We probably don't want that because, well, what are you going to do with a shape? You don't know what kind of shape it is. You don't have enough information to do anything with it. So that would be a good candidate for a interface.
And then the difference between the interface being an empty set of methods and an abstract class. An abstract class would already have something defined within it.
Only if you, as the developer, actually define it, right? So you can have definitions in abstract, but you can also have abstract methods. Interfaces can only have abstract. Abstract classes can have both, but you still can instantiate abstract classes. Oh, hey, that worked. I was holding it, expecting it to fly up, and it didn't. You just clicked on, right, Taylor?
What's that?
For this?
Yeah, wrong about the giant one.
What is this one for?
You just turned something on. Don't know what the.
Oops.
Turned it off.
Oh, what if it's?
You'll find out.
Yeah.
It's not that. I don't want to find out. Just make sure this doesn't fall asleep.
That'll be the computer. That'll be the first door. They'll just create it like that. The data has to get just finished.
One more thing about generics. Well, it loads up. In a generic class, you have to have it's the class name and then the little diamond brackets and then the variable. But if you're planning on using a generic, like you're trying to use, it's a method. No, it's in a class that's not using generic types at all. But if it's just a method by itself, it has to have the little diamond brackets in the method name before void before after the public or
generics are only required in the symbols are only required in the class declaration. And then the identifier is what you use in the class declarations, right? Is that your question?
I'm trying to see like just how is it written out when it's used within a class name versus when it's in a method, basically.
So in a method name, you don't use the symbols, just use the name of the generic. You define the name of the generic in the symbols of the class declaration. Does that answer your question? We can write it out.
Okay.
So this is cut off over here. This is just the project directory thing or project hierarchy. So can you guys see all the code and stuff? Yeah. All right, let's do that shape example thing. shape.java. So public to interface, because I want my shape to be an interface.
Is this inheritance or is this polymorphism?
We're gonna start with the earlier one. What was it?
Shit, you're scaring me.
So we're doing classes. I'll do Java docs. I'll do inheritance first. So this is the inheritance, all right?
I just
Okay.
understand how I meant.
So I got my public interface shape, right?
I'm not going to sit there.
I'll start with a default constructor.
There's so many things you need to get just to be able to get started with design tree.
What are
You have to have the interface on file.
Can you think of anything? Let's do a string name. Wait, no.
Already kind of lost. the
Interface.
and I'm just not willing to do that one.
I'll just do. Right, interfaces have just method declarations. Okay. What do we want to do? Rectangle, right? That's where we'll actually start defining properties. So then we do, what is the keyword for extending, what is the keyword when I want to implement things from an interface?
Extend.
Such shape, but it needs to be rectangle. So extends and then the name of the class, right? And then I said it needed to, needs to do this. So with an interface, I got before I can compile it, the class that extends an interface has to implement all of the abstract methods. So in the rectangle, I'm going to define area real quick. And then my main, I'm just going to set up a.
Well, worst case is I fail this and I just have to do a different, lab next semester.
Will this work? Am I able to do this? Because I didn't define a constructor. Will it let me do this?
Good luck.
Yeah.
Okay, see if I have any compile errors.
If you're desperate, you can get more. hours
Public.
in the comments.
I did capital P. Lowercase.
Wasn't trying to be mean, I'm just
No,
thinking at least you have a source of income.
I do always have a system.
Okay, so it's the same. Error class interfaces are in unexpected. Oh, that's right. So in shape.java, I said interface shape, right? But I want this to be a concrete class, so what is the keyword I need to put here?
Static.
Hmm?
Static.
Not static. So this is a class declaration, right? So what is the keyword for classes?
Yeah, I think there should have been
Can you?
specific stuff supposed to find the environment material. Should have just been so line it should have been.
That's what I was missing, right?
Yeah.
So when when defining a class, and it's not an abstract, it has to be class. The keyword is class, right? So hopefully it'll compile now.
And then Wednesday night, our finals have an algorithm to do that. It's not like a 2 hours of class. So
Hmm.
as much as you can say, you check it, something like that, you could do 8 hours.
Still having issues with this. Anyway. Oh, do I not even need public? No interfacing. Okay, so we said extends, but extends is for concrete classes, right? So what is the other keyword for implementing interfaces? I'll give you the hint.
Implements.
Does that make sense? So implements instead of extends?
No.
That's a that's an important thing to realize. So if you're trying to extend an interface, it's implements. You're implementing an interface. If you're extending another class, in fact, we'll get there. Because shape is an interface, I had to implement shape, right? Everyone got it? Okay, so, and then shape has the abstract method calc area, so I went ahead and defined that in rectangle. So now let's look at method overriding, right? I said I wanted a square class, and square is going to, this is where I'm going to extend, right? I'm going to extend a rectangle, right? Does that make sense? And it extends, right?
So,
And here's
I'm
where,
sorry, but go over extends versus the other one. again.
okay, so at the top of the hierarchy, I have shape, right?
Yeah.
Shape is generic,
Yes.
or generalized, I should say, not generic.
Mhm.
So, and since it's an interface, it declares a method called calc area, right? So now I want to start defining another class called rectangle, right? And so rectangle is going to implement the interface shape. So let me put that in a comment. Implements
Hopefully this will be worth more than a
implement shape, which is an interface, right? So because I'm implementing the interface shape, I have to do this. It implements.
So that turns it into a double and return.
It doesn't. This is the declaration. I have to use exactly this because of this right here.
Okay.
So it has to have the same name, same modifier, same return type, and so identifier, return type, visibility. It's all the same with when you're implementing abstract methods. Make sense?
Kind of.
Okay, so what are some properties of a rectangle? Just length and width, right?
Yes.
Let's make them doubles. Because I respect encapsulation, I'm going to define them as private, right? Now let's do protected. What is the difference between those two?
Private can't really be accessed. Protected can be accessed by all of the method or
Children,
the children.
right? So I'm going to have protected double length, and then protected double width, right? At this point, I'll go ahead and do a custom constructor, which is how I define what the properties are going to be, right? If I could spell. So, what is true of a constructor? What does it have? The name have to be?
The same as the class.
Right. Since this is a custom, I would need the double length. Because I used, because the parameters have the same name as the identifier, what keyword do I have to use to specify that I'm assigning to the class's properties? This, right? And then this dot width. Okay, that's about it for this one. Okay, so in method overriding now, right? So we just kind of ran through interfaces. This is the this would be the super class. So now we're gonna do, yeah, we're doing inheritance and method overriding, right? So I'm extending rectangle, so this is for inheritance, if I could spell, right? Because it's inheriting, it can see length and width. Okay, so let me explicitly write this calculate area, right? So how do I calculate the area of a rectangle?
Length comes with it.
Right, and I have properties length and width that I can use, right?
This is still interface, correct?
Sorry, what?
This is still the example for interface?
Past interface.
Huh?
We The interface was shape, right?
Okay.
Can you think of anything else that a shape needs to do? So a shape needs to be able to calculate its area. What else should a shape be able to do? Can you think of anything?
Calculate volume.
Volume, that's a good one. So in my interface, I'm defining that a method called calcArea_volume will exist, right? Without defining it. So in interfaces, I declare that a method called calcVolume is a method that needs to be implemented. Does that cover, or do you get it? So that's basically it with interfaces, right? I can't think is there anything else with interfaces? I can't think there's anything else that is really notable. So, any other questions with interfaces? Is it good? Got it, Carlos?
Give me 1 second. Copy this.
Let me make sure this is still recording.
Okay, so all the stuff that we've been doing, then if that's not interface, what would that be?
So rectangle would be superclass. So this begins inheritance, right? And then rectangle. So here's the other part to interfacing and to implements, right? You have that?
Yes.
Okay. So with shape we have interface. With rectangle we have superclass, which begins inheritance, right? Got it? I'll email whatever code I type out to you guys. So we should keep moving, all right? You got it? Okay. So with rectangle we have the superclass, which a superclass is required for inheritance, right? So in the square, we're naming square as the child class of rectangle. Make sense? So with rectangle we have a calculate area, which does length and width, and now because I did volume, we need to go ahead. Here's also another part to interfacing. Because I declared a method called calculate area, I now need to define it. So volume for a rectangle, it's not a 3D object. Does that matter? It does matter, right?
Yeah, 2D objects can have volume.
I'll just return 0 because 2D objects has volume of 0, right? So that's all we need for that. Is that the same name?
No.
LUMN. Alright, so we just shown here that calculate volume is defined, right? So now we can move on. So with square, square has a special way of calculating an area, right? So at override, right? Public double calc. So this is important right here. This is how you override a method. Because the child class rectangle has a method called calcArea, and in my child class square, I'm overriding calculate area, such that if I instantiate a rectangle that stores a square, override will call the squares version of area instead of the shapes version of area, and that's polymorphism, which we'll get into right after this, right? So with a square's area is just the length times length, right? Because the lengths are equal to each other. So here I'm just going to do length times length, because I don't want to import math. I can just, because otherwise I could also express this as length squared, but we're just going to do length times length. So let's also do a custom constructor within square. Same name as the class because I'm doing a constructor, right? Let's do. I'm just gonna have length in this custom constructor because we don't want to differentiate between length and width, right? Okay, so how do because square is implementing rectangle, what is the keyword I use to assign to properties of a superclass?
Is it super?
It is. Does that make sense? And I would say super dot, what? What am I assigning to here?
Wouldn't that be the name of the class?
Not the name of the class. Super takes care of that part.
The method?
Just the property. What property am I assigning to? Ooh. Length, right? So super.length equals length. So notice the difference here, right? So in rectangle, I did this dot length equals length, right? But in my super class, my child class that extends rectangle, super.length equals length. Is that clear? Cool.
So you have to specifically do super dot length. It doesn't automatically know if you're inputting a length. It doesn't automatically go back to this the parent class and assign that variable to length.
It would had I not used the same name. So like for example, if I change the parameter name here and I just named length, right? The compiler would be able to tell, hey, this length identifier is not defined within square class. Let me look to the parent class. The compiler would do that if you don't specify super. However, the name of the thing I've been preaching this whole time, explicit, is better than implicit. So square constructor has length as its parameter because length is what I'm assigning to, and then I use the keyword super to then assign explicitly to the property of the parent class. But like you said, it works the same way as the this thing does, or whatever. I forget what we covered when you, because there was a question that was similar to that, right?
Yeah, it was. Yeah.
So compiler will do it. Oh, it's with the override, right? The override, the compiler can intelligently tell that you're overriding a method that already exists. The compiler will do that, but it's better to hold Java's hand than let it do all the work, rather than not. Okay, so that covers method overriding and inheritance. What was the next thing to move on to? Polymorphism, right? So I'm going to use arrays with this one. Oh, sorry, lost where I was at. So let me go back to the main now, right? So in my main, I want a. Okay, I'll leave that in. Let's see if this will compile. Let me see if I goofed up or anything. Oh boy. Constructor and rectangle and class rectangle cannot be applied to given types. So that's a main. Let's give it a width of 1, 2. Okay. Rectangle is not abstract and does not override calc volume. I thought I did. Huh.
Your calc volume is
so in the shape.
spelled incorrectly.
Ah.
I bet it's like clack volume on one of them.
Oh, haha. Calc? No, wait.
That was there was another. Your volume and then another.
So
Yeah.
CALC. Ah, typo. So that should fix that compile error, right? Hopefully. I bet it does.
I think he's still doing the 1302 tutoring, so we're finishing that up right now.
Yeah.
Did you have a particular question?
Constructor rectangle and class rectangle cannot be applied to given types. Hello, what's happening here? Is it? Actually not sure why that's complaining the way it is. Constructor rectangle and class rectangle will not be applied to given types. Is there a syntax error going on here? I can't tell. I can't tell. Huh. Looks like it's happening in this. Oh, it's wrong one, 6. Squares. Oh. So it's happening here, right? In class square. It's saying that constructor and rectangle. I don't know why that would be happening. Let's see if commenting it out fixes that error, or is it still an error? Constructor rectangle class. Bro, what are you doing? I'm refreshing it. Okay, I'm trying to instantiate a rectangle. It's saying the error is in square, which doesn't make sense.